the equation of a straight line is given as x over 3 plus y over 7 is equal to 1. The line crosses the y-axis at Q. Determine the coordinates of Q. What is the gradient of the line? First of all, if the line crosses the y-axis at Q, then we call Q the y-intercept. And of course, we'll take a look at the finer details of what the gradient of the straight line represents. The general form of the equation of a straight line is y is equal to mx plus c. That is your general form of the equation of a straight line. There's no secret. Y is in reference to any position relative to the y-axis. X is in reference to any position on the line relative to the x-axis. And of course, these are what we are focusing on. The gradient, which is m, and c, which is the y-intercept. And for the intents and purposes of this problem, it is called q. There we have the gradient and the y-intercept being labeled on this occasion for reference and for comparison as we solve the problem. The gradient is the rate at which y changes relative to x. The y-intercept is where it crosses the y-axis. And the y-intercept on this occasion is q. The gradient is the rate at which y changes relative or with respect to x. There we have our equation as given in the statement of the problem. Right there. The best way to analyze the equation is to write it in the general form, attainable by transposition. We will therefore write this particular equation in the general form, and we are going to achieve that by the process of transposition. We need this equation to be in this exact form. Y is equal to mx plus c. The equation of the straight line may be analyzed irrespective of the form that it is in. However, if we write it in the form y is equal to mx plus c, it makes our work tremendously easier. First, eliminate x over 3 that is accompanying the y term, and that is on the left hand side. Notice that we have on this left hand side y over 7. Also we have x over 3 on that same left hand side. What we want is, as you see here, y all by itself on the left hand side and everything else on the right hand side. And not merely everything else on the right hand side, but the right hand side needs to have a form exactly like this. So we will proceed first by eliminating all that we have accompanying the y on this left hand side in order that the form may be exactly as we have it there. Eliminate everything that is on that same side. Now, what we will eliminate first is that x over 3, and no doubt it's of a positive value. We will therefore eliminate it by subtraction. Do not forget that whatever we do on one side of an equation in order to change its value must also be done to the other side in order to change its value in the same way. So we are subtracting x over 3 from both sides. Now it should be noteworthy that what we have on the right hand side, instead of having 1 then subtract x over 3, what we have done is that we place the negative x over 3 as the first term on that right hand side, And the great reason for doing that, we are just being true to form. And the form requires that, as we have it here, that the term in x goes first. We will place the negative x over 3 first. Now, there should be no discrepancy, because if we have 1 subtract x over 3, that will give the same result as negative x over 3 plus 1. It does not matter where we place the terms, as long as the overall value will be the same. Continuing, the x over 3 is already eliminated, and what we have here is y over 7. The 7 by which y is divided must then be eliminated. This will be done by multiplication. We are dividing by 7 here. We need to eliminate the 7 that we are dividing by. We will achieve that by multiplying by 7. And as you imagine, we need to do the same on the other side. Since the other side must also be multiplied by 7, we may as well multiply the entire equation by 7. So both sides will be multiplied by 7. It's the same thing as multiplying the entire equation by 7. We have done that all the time. It is just that we are making mention of it for the intents and purposes of doing it individually, one at a time, to each term. So let us go. We'll multiply each term throughout the entire equation by 7. We see the 7 multiplied by y over 7 right here, and we multiply the x over 3, which is the negative x over 3, by 7, and the effect is the same as if we just multiply the x by 7. And there's no doubt, seeing that we multiply 1 by 7 right there. So the y over 7 is multiplied by 7, the 1 is multiplied by 7, and the negative x over 3 multiplied by 7 in that special way, which we just multiply the x by 7, which will eventually have the same effect. Consequently, the 7 is eliminated all entirely from the left hand side, and what we have remaining, of course there's no doubt, just 1 multiplied by 7 is the only different form that we have there. So we have y is equal to negative 7 over 3x plus 7, and that equation is in the general form as required right here. There's no difficulty in identifying the gradient and the y-intercept. So the gradient will turn out to be negative 7 over 3, being the coefficient of x. When the equation of a straight line is in its general form, the coefficient of x is the gradient of the line, and the constant term will be the y-intercept, as we have it there. So m is negative 7 over 3, which is your gradient, which is a requirement of the statement of the problem, and the y-intercept, which is given in the statement of the problem as q, is 7. Now, what we have here is by no means the coordinates of the y-intercept or the coordinates of q as required in the statement of the problem, but we are not done yet. The gradient is negative 7 over 3, and the y-intercept is 7. Take a look at the actual line. So we have the actual line there. So we will take a look at the actual line and see how the gradient and y-intercept apply graphically. So we are not only just doing an abstract representation of the equation of a straight line, or if it is not even abstract, an algebraic representation. We are not only doing an algebraic representation, we are also demonstrating this. This is not a requirement of the statement of the problem, but we are doing it for demonstration in order that the students might have a better understanding of what all of what we did means. So we have a gradient, and we know that the gradient is the rate at which y changes with respect to x. As the x value changes by 3 units positively, so if we take a look at this, 3 units positively, that is the change in x, 3 units positively, there it is. Then we are going to take a look at how y changes. So how does y change? The y value changes by 7 units negatively. We have a change in x, and we need to consider now the equivalent change in y. And we can see right there that y changes by 7 units, but also that it is going down. Because it is going down, we are sure that the change by 7 units is in the negative direction. So it changes by 7 units negatively. And that is your gradient. M is equal to -7 over 3. And we are looking at C, which is the y-intercept. The y-intercept is the point where the line crosses the y-axis. The y-intercept is the point where the line crosses, and we can see that it crosses the y-axis right there. So the y-intercept is that point where it crosses the y-axis. So C is equal to 7, and that is the y-intercept is equal to 7. There we have our gradient and y-intercept. Or we take a look at another way in which we may find the y-intercept. So we have found the y-intercept, but as yet we have not stated its coordinates. So we are just going to continue until we get to that point. For any non-vertical straight line at the point where it crosses the y-axis, which is the y-intercept, the value of x is equal to 0. There we have it, where it crosses the y-axis, and we are taking a look at the corresponding x value. And we can see that it crosses the y-axis here. The corresponding value of x is 0, as we see there. So we may take the same equation of the line that is given to us and substitute the value of 0 for x. Substitute 0 in the place of x into the equation. So there we go. X is replaced with 0 because at the point where the line crosses the y-axis, the value of x is equal to 0. The entire term will be equal to 0 and will not affect the sum on the right hand side. This term is going to be 0. 0 divided by 3 is 0. So the only terms that will remain in the equation will be the y over 7 and 1. Y over 7 is equal to 1. Find the value of y by eliminating the 7 that it is being divided by. When we find the value of y, we would have found the y-intercept. And as we have it right there, y is being divided by 7. We need to eliminate that 7, and that will be done by multiplying by 7, because we are dividing by 7. And no doubt we need to do the same on the right hand side also. Multiply by 7 on the left hand side with the intention to eliminate that 7 that we are dividing by. Balance the equation by doing the same on the right hand side in order that the right hand side will experience the same change. So our 7 is eliminated from the denominator on the left hand side, and on the right hand side we have 1 times 7 is equal to 7. So the y-intercept is 7. The x and y values at the y-intercept will be its coordinates. There we are right now, taking a look at the coordinates. And the coordinates will be what? The x and y values at the y-intercept. That's your coordinates, your pair of coordinates. So take note that where the line crosses the y-axis, the value of x is equal to 0. The line crosses the y-axis right here. The value of x is 0. So that will go right there. Right. And of course you see the value of y getting in right there also. Also, we may take a look at the fact that we substituted 0 in the place of x. So 0 in the place of x, and the y value is 7. So irrespective of the way that you take a look at it, you'll realize that the value of x at the y-intercept is 0, and the y-intercept itself is 7. So the pair of coordinates will be 0, 7. Teachers and instructors, get unlimited access to teaching aids for your virtual classrooms at richardjamesmathematicsresources.com. Also, this is the best place for the hearing impaired to master mathematics as long as you are literate.